Hello everyone. Today we'll be presenting the student grade calculation system. These are my team members and these are the content of our projects. Next is introduction slide. The system is designed to automatically calculate student grade and its GPA, which removes manual error and saves time. The system ensures accuracy, reliability, and complete data security. We have tested all modules include login, grade, calculation, PDF generation, dashboard, and a database connectivity to make sure everything works smoothly. Testing validates all modules such as a login, grade, and other systems. Next slide, system design and architecture. Our system follows a three-tier architecture which divides the software into three main layers. The first layer is a presentation layer. This is the user interface where students and admins interact with the system. The second layer is the application layer. This layer contains all the logic such as authentication, grade calculations, and validation. The third layer is a data layer. This layer stores all information like marks, user details, and reports in the database. These structures make the system cleaner and more organized and easier to maintain. Next slide, high level architecture overview. At a high level, the architecture still follows a three-tier structure. The presentation layer is the user interface on a mobile or a web. The application or a surface layer performs all business logic, authentication, validation, and workflow management. The data layer is a centralized database where all data such as transactions, logs, and user data are stored. This architecture improves security and performance and keep every layer independent. Next slide, architecture diagram. This diagram shows the complete working flow of the system. In the presentation layer, the user enters data through a mobile or a web app. The data is then sent to the application layer where modules like grade calculation, authentication, reporting, and audit perform the required operation. The application layer interacts with the data layer to fetch or store data. Finally, the results are displayed back to the user to the presentation layer. This architecture supports modularity, easier updates, and better scalability. This is a simple architecture diagram for student grade calculation system where it includes grade calculation module, authentication module, reporting and audit module, a web app and or mobile app which sends the user interface input grades, displays results, and the database data layer which includes database or cloud storage which is set to be persistent storage, stores student data with SQL or no SQL queries. And this three-tier architecture promotes a modularity, easy update in agile, separation of concerns waterfall, planning, scalability, cloud deployment. The main strategy of the student grade calculator is the basic logic is compute the GPA and validate the data. Where it there is a two parts authentication model and reporting and audit model. Next slide, scalability features. Our system is designed to scale easily when the number of user increases. It supports horizontal scaling, meaning more serves can be added when needed. We use a stateless API design which improves performance and makes load balance easier. Catching is applied to reduce serve load and increase speed. Database indexing ensures faster searching and overall better system performance, supports horizontal scaling. This system is built to handle more users in the future. It supports horizontal scaling, uses stateless APIs for better performance, include caching to reduce load, and apply database indexing to improve speed. These features help the system work efficiently even as usage grows. Thank you. Next slide will be continued by Bindu.
Myself, Bindu. Myself Bindu SP, and I'm here explaining about maintainability features. Uh, this title indicates the slide that the qualities make the software easy to and maintain, update the and improve. Modular layer structure. This means the system is divided into separate layer or module like UI, logic, and database. Each part is independent to source, so changes in one model do not affect others. Next, high reusability. Parts of the code can be used again in other projects or models. This reduces development time and improves efficiency. Next, logging for error tracking. The system keeps logs, records of activities and errors. This helps develops identity problems quickly and fix them. Next, clean separation of UI logic database. The system clarity separates like UI user interface, what the user seems, and logic. Logic here, how the system works internally. Next, database, where data is stored. This separation makes debugging and updating easier. Next slide. System models, use case model. This system model that session introduce the use case diagram, which shows how the user interacts with the system. Use case diagram that shows the represents the person using the system and central action. It shows the entire marks. This is the main operation the user performs, like other operations depend on this one. Next, calculate grade. This means calculating the grade is included whenever marks are entered. Next, view student reports. After entering marks, the system allows viewing the student reports. Next, update grade rules. The system includes an option to update the rules for calculating grades. Next, generate the system report. The system can generate a complete semester report based on the entire marks. Next slide. Class model line by line. Here I'm explaining. Uh, This class model for student grade calculator shows the structural design of the system. Classes visible, like first one is student, attributes, student ID, name, and course list represents a student using the system. Next, course, attributes, then course ID, then course name, and then credit hours. Next, it stores the subject related data. Next, grade calculator, like methods calculate grade, and it will generate the GPA, and it handles grade computations and GPA calculation. And next, relationships. A student course, like a student can have multiple courses. Next, grade calculator. This student course grade calculator uses both the classes to compute results. Next, sequence model. Here, the sequence model shows the how the flow of message between the objects, like actors, objects, like a student, user, and grade calculator system and course. These lifelines of the messages, like enrollment page, like a student, your student grade calculation, like entire course, and a student enters course details, and grade calculator like course store and the details of the students. Next, the grading page, student grade calculation and submit of the student marks and grade calculator course like attach marks and grade calculator students to return GPA value. Next, activity diagram. This diagram shows that the flowchart of this login to GPA generation like activities, user logs in and select student and course decision is like a data valid, if no display error message, and if yes continue, these are the decision is data valid. And next, retrieve grades from database and calculation grade, calculate GPA and generate report grade GPA remarks and send notification email and SMS. And next, display results on UI and login activity for uh, and these are the these are the activities that shows the flowchart of the login of student GPI and start and endpoints. Like I can say that class model, this system structure class model shows the system structure, student course and grade calculation. And sequence model, this shows the how student interacts with grade calculator and by step. And this activity diagram shows the entire workflow from login to result generation. Thank you. Next will continue by Mahalakshmi.
Hello everyone, myself Malakshmi. I am explaining about activity diagram. Activity diagram for the suitable grade calculation process for the report student GPA. The student user and teacher user and login. The user logins in the two system. The successfully automation the process to select the student and course. Input validation, the system check whether the selected input are valid. If valid, system move forward. If not valid, display an error message that ensure the data accuracy and the system. Retrieving the grade, the system fetches the grade record stored in the database in the selected student and course. GPA calculation, the first calculate the average grade. The GPA based on the credit formula and weighted formula. Step core business logic of the system. Reporting, user can choose to full report consists GPA consists letter grade, course performance, notifications. System may send the results through email and SMS. Display in the logic final result. Show and the UI. The activity is logic logic for addicting the feature tracking. Importance, this diagram is the student and teacher login purposes. Next, data flow diagram. And the level 0 DFD is consist level diagram that show the system as single process. External entities, enter the student's grade. Student view the calculation grade and GPA. Input to the system, student source, grade scheme for ABC range like. Processing, the system performance grade validation and GPA calculation letter grade consideration. Output will like this final numeric grade or letter like and GPA values. Importance, what output will come, what goes out, what the system does, the help understand the system for clearly. Next, model distribution. This is model used management module like registration, login, authentication, role assignment. This is handle the logic, provides the authentication, used role for teacher and admin students. Core functional module. This is exist primary system operation business logic validation. This is performance all the main operations, grade entity GPA calculations business logic and validation in the applications. Database models, data storage, indexing, backup, retrieval. This is storage of the student details, grade and courses, performance indexing, and handle booking up recovery, ensuring the data retrievals. Next, notification modules, email, send alert, system messages, send the alternate Vivo SMS or small send like emails used for grade updates for reporting generate use in the notification modules. Security modules, this is access control for the handling, implementation encryption session and access control, protect using data. Admin module, dashboard controls monitoring configurations. This provide the dashboard and system monitoring configuration control and manages system wide settings. Next slide. Design principles. This is modularity functions. Components are separated for clearly and reuse. System split into logical modules. Each modules handle one responsibility, easy to maintain and existed. Abstraction, interfaces, hidden complex internal logic. This is internal logic and only necessary for detail export. Elf, simple, complex and operations. Encapsulation, data plus logic keep in the inside classes. Low coupling and high coherence. This is model depend less and each other, and each module for focusing system complexity and debugging. Secure coding practices, input validation and process for SQL and other. We use the safe sections managements. Scalable architecture, support the handle growing numbers for users, suitable for the distribution in the system. Next slide. Implementation plan. Tool users with Python programming and Java and Node.js. Python else faster development, Java higher stable for the large application, Node.js fast for back APIs. Frameworks, Django Python based web framework, database MySQL structured and secure data storage. Development tools, GitHub, uh, team collaboration like that we use. Next will continued by Sania.
Miss Anya. I will be presenting the next slide of our project, that is testing strategy. This slide covers the testing process. We perform the unit testing, integration testing, system testing, UTA, that is user acceptation testing, and the performance testing and security testing. Now, first, we perform the unit testing to check the individual functions and the modules. Next, integration testing was done to make sure modules worked together correctly. System testing was helped to us to confirm that the complete application works without issues. We also check the performance testing and the security testing to ensure that the system is reliable and the safe for the real use. Next is about the sample test. Sample test cases is for the valid student login, invalid student login, marks validation, non-numeric input, grade calculation, PDF download, and the dashboard graph loading. So these are the examples test case we used during the testing. Uh, we tested a login with the correct and incorrect credential. We tested marks entry and the grade calculation to ensure the results were accurate. And also we also tested the features like generating reports and viewing the results on the dashboard. This test cases help to us to detect the problems and early performance and improve the systems before the final deployment and sorry deployment. And the error handling test to confirm the system responds correctly to or the wrong inputs, the dashboards and the report generation test and the test to ensure the results to display properly, and everything was done. Next is about the security. This slides talks about about the security features in our system. We used input validations to prevent the error and avoid miscellaneous data entry in the systems. Access control ensures now the access control ensures that the only authorized users like admin or the staff or the student can update the marks or the view the sensitive data. Only students can view the data, whereas the staffs can see the update and update the marks and sensitive data. So we include the secure section handling and protected the data storage to keep the student information safe and encrypted. At the last, I conclude that our student grade calculation system successfully optimizes the grade process. It reduces the manual work, avoids the calculation errors, and provides the secure information of the student data. This system meets the both functional and non-functional requirements and work efficiently for the academic use. The project delivers an efficient solution for the academic and the results for the processing. The architecture is secure, reliable, and easy to maintain. It provides fast, accurate, and consistent results for the students. The system automates the grade calculation and reduces the manual error. Thank you.